sir. Um, Good morning to all who joined today's our webinar. I am Hetal Prajapati, Head of Diploma Electrical Engineering, Parul Institute of Engineering Technology, Diploma Studies, Parul University. I welcome all of you for today's our webinar on topic application of the switchgear. In today's webinar, expert will cover importance of switchgear in power system and application of it. We will also discuss some case studies. Now, I would like to introduce today's expert, Mr. Viral Kaka. He is our alumni. I feel proud to say that he is our Parul University's alumni from first pass out batch of Diploma Electrical Engineering PITDS. At present, he is Senior Electrical Engineer, this infrastructure, Google, United Kingdom. He has also worked as electrical design engineer at Wood, UK from 2017 to 2021. He has 9+ years of experience as electrical design engineer in the medium voltage switchgear industry. He has worked as a lead engineer on several domestic and international projects, which covers scope from tender review, design, testing, assistance, and in factory on-site support for medium voltage switchgear and medium voltage starters. There are many more technical achievements for the Viral. So I just briefed given the introductions. Thank you, Viral, for joining and giving the 1 hour for our students and our university. Now I would like to over mic to you. Viral, please start your presentation.
Can you hear me, fellow distinguished
Yes,
members
yes.
and Madam Censor? Can you hear me? And is my screen
Yes.
clearly visible to all?
Yes, Viral, yes.
Yeah. First of all, thank you very much for giving me this opportunity, madam. And it gives me a chance to interact with the phase which I have been once in my lifetime. So first of all, thank you very much. And I'm pretty excited to share my any of smallest of an experience which can guide anybody until now, which I have been passed through. So I'll be happy to share any of the details as well as any particular thing which our students will like to know from my side, so that they also can. I'm not saying that they can follow exactly my path, but at least they will give. It can help some bit of clarity in terms of direction and how to proceed further once they step outside the college, and which areas needs to be figured out, and how they can progress further in their life, which can make their as well as their family life better. So once again, thank you very much and welcome all of you. I'd like to start my presentation. The prezzo in just to give slight bit of over idea in terms of this particular presentation, and bit of my background in an industry. I have been purely working in the medium voltage switchgear segment since last 12 years now, and it's morely purely based on the product side. So I was working as a protection control as well as protection engineer, but protection engineer was something on the lesser part, controls on the major part, as well as along with the product development and looking to the overall projects cycle. So that's what my experience and my expertise lies in terms of working with vendor to vendor, different manufacturers to manufacturers. So I like to cover that bit of part in specifically related to medium voltage switchgear in this preso. So now, as we all know, that medium voltage circuit breakers are literally switching devices which are required to clear a fault as fast as possible. So this preso just gives an overall brief idea in terms of what are the circuit breaker and circuit breakers are required to clear faults as fast as possible. It is required for a current have an integrated current monitoring and the protection facilities as well. But in the most cases, external current transformer as well as protection relays are required to trip the circuit breaker under normal condition. Now, as we all know that whenever there is a fault inception on the circuit or there is any fault initiation, it will be triggering that fault and then passing through to open the circuit breaker. So this is just a brief explanation in terms of medium voltage circuit breaker. Following details down here is an is an IP rating, is an IP class, we can say as an asymmetrical peak let through fault current capacity from the first loop. Normally it's 2.5 times of an IS and 2.6 times of an IS for 50 as well as 60 hertz. This is just a waveform of our fault current. Now, as we all know that during in a fault current waveform, we don't normally see only an we don't normally see only an RMS current. There will be also a bit of DC component in our fault current. So that will be having a slow decay, and that's what it makes as an asymmetrical RMS current. So normally medium voltage circuit breaker tends to be in either vacuum or an SF6 insulated. Prevailing in an industry, it will be these are the breakers which are used extensively, vacuum as well as SF6. People are moving from an SF6 gas, considering an environmental hazards or greenhouse effect because of SF6 gas insulated breakers. They are nowadays moving towards more of a free air, or we can say an environmental friendly gas, and that's the concept of the industry right now. But vacuum was always a prevailing technology and it's still being used, but the alteration from an SF6 gas, the industry is shifting towards the cleaner air nowadays. This is just an overview in terms of medium voltage breaker and an SF6 breaker. The as the operating currents from for a medium vacuum circuit breakers in a medium voltage switchgear, it can be from 1600 to 1600 ampere, 2000 ampere, 2500 ampere. It can go even for 3150 ampere with the force cooling. It can even go to the 4000 ampere for a switchgear along with the force cooling. So, and also the switchgear has a capability to interrupt the fault up to 40 kA. It starts from a 25 kA and then rises upwards right from 25 to 31.5 and then 40 kA in terms of its fault clearing capability in a switch gears. Below is just shown as another details in terms of gas insulated switch gears. The only major advantage in terms of using a GIS apart from an air insulated switch gears, which in a way both has a vacuum interrupting bottle, but the fundamental difference is that the vacuum interrupter in a gas insulated switch gears are in inside gas tank. So in a way the footprint of an overall switch gear reduces drastically, at least by 30 to 40%. If suppose we are going with the gas insulated switch gear, that gives a good bit of floor space saving in the substations, as well as the area where we are seeing a shortfall in terms of spacing. Deploying the switch gears in terms, we concept is also to deploy this sort of switch gears in an e-house in a complex substation. So that in that particular area, SF6 gas insulated switch gears as well as breakers works better. Now, this is just a basic technology. What has been circuit break? What is actually driving the circuit breaker? Breakers are just an electromechanical driven using magnetic as well as stored energy techniques. Normally, a vacuum circuit breakers are having a closing as well as opening springs. Each spring is charged with potential energy. It's been held in with that particular charge by a motor operation, and by using a manual operated handle also you can charge the spring in case if suppose we are losing any auxiliary power. So the basic design of the switchgear lies that whenever you are making any closing as well as opening operations, straight away it triggers once again back to charge the spring so that any further operations can be catered by the breaker. But even if suppose there is a loss of auxiliary power, you can still do that by an external handle which is being provided as loose accessories by the vendors. Also, the mechanical operation for the main switching contacts occurred by releasing the potential energy from the charge spring. So that is the point which I was trying to make here. Spring release is activated electrically by use of small opening and closing solenoids or by the manual push button. So there is a push buttons as well as TNC switches which are given there. So you can easily release that's been activated by using small opening and closing coil. Now, withdrawables are coming to the next point in terms of withdrawable circuit breakers. Most Indo switchgear installation uses withdrawable circuit breaker, but uh, talking about the industry and the practices, especially being followed in UK, or maybe nowadays it's practice in India as well. That a lot of uh, state utility companies as well as national utility companies are shifting from an AIS to gas insulated switchgears, considering that they can accommodate more number of feeder, more number of panels, and achieve the same feeder count while deploying versus air insulated withdrawable circuit breakers. So that is another point. Whenever this is just an fun overall architecture of a medium voltage switchgear. Uh, can you all see my cursor here? Yeah. So whenever withdrawable breaker is integrated in a metal enclosed switchgear, it has fundamentally breaker compartment, bus bar compartment, cable compartment, VG compartment, and as well as LB door compartment. Now all these compartments are from a design point of view as well as the type tested switchgear point of view. These are all metallic partitions. So the point here is that whenever you are doing any maintenance activity of any of the one of the compartment, you don't need to see that you can do the maintenance activity. Let's say the you are doing any cable crimping activities or cable maintenance activity on a cable compartment, irrespective of bus bar energized, or you can still do that activity because it's been completely metallic partition in that area. But practice is to have a complete earthing in that case towards the cable side, and then do the maintenance activity on the cable. But your rest of the feeders or the section of the board can still remain live. So that was the point which I was trying to make here. Also, there are a couple of interlocks in terms of this switch gears as well. Cannot open the door unless and until it's been completely opened. There are a couple of interlocks associated with the breaker plugs as well. There are a couple of interlocks associated with the breaker position as well. Means normally industry practice is to use Castell as well as Ronnie's keys, which are further used in the key exchange boxes for the premises to have a safe means of isolation and providing a operator safe from the operator safety perspective. All these things are being electrical. Uh, all these things are being derived from a safety perspective. So let's say somebody requires the lock or the key which looks for the breaker in isolated position, or we are doing any bus bar maintenance activity. So we will rack out all the breakers possibly connected on that particular bus bar, have the keys of every single individual breaker, and then go to one key exchange box and then perform the bus bar earthing operation. So it is ensuring the operator that every single breaker it's been isolated from that particular bus bar, and now it's safe to earth on the bus bar. So that's how the standard practice is being followed in an industry. Now, these are just an overview in terms of the ratings of the switch gears which have been offered in the medium voltage switch gear. It's been right from 3.6, 7.2, 12 kV, 17 and a half, which has been followed in 17 and a half for some of an EMEA region, 24 kV, and 36 kV as well. Again, these are all being type tested at 50 as well as 60 hertz. So irrespective of that frequency variation, you can still use your product in any of the countries which is been using 50 or 60 hertz. And the rated current, again, as what I said that as per previously, it starts from 630, then 800, 1000, 1250, 1600, 2000, 2500, 350, and 4000. Normally, on the secondary distribution level, where you see a secondary switch gears, how that is something. Switch gears are being categorized into primary as well as secondary. Secondary switch gears are somewhat limited to its short circuit capacity as well as by the breaker current. So normally the product variants such as ADJH and ABB, Safe Plus or Safe Rig and that sort of products are limited to its short circuit capacity. Even the breaker carrying capacity of that sort of products is somewhere around only 630 ampere. So there is a limitation, but that is purely used for the secondary purpose, or you might have seen windmill units and that sort of application, which nowadays utilities are using since a long time. So that is what I'm trying to address here. Primary switchgears are always which are seeing which are which are seeing a higher short circuit levels capacity to interrupt, right from 31 and 25, 31 and a half, and 40K. And also for that, the minimum breaker capacity or minimum breaker rating starts from 1250. So that's how the panel design or the structure is being type tested, because it has to achieve a certain temperature rise limits as well. It has to achieve the short circuit and pass the short circuit test as well. So in terms of width, in terms of cubical depth, also volumetric space also plays a major role whenever you are testing the breaker for a 40 or 31.5K. So that's what your minimum breaker capacity comes into picture. Again, this is the same slide, so I'll quickly run through this one. Normally, the short circuit durations are 3 seconds as per the practice, but you can still get 1, 2, or 0.5 seconds. But that is not something as a conventional practice. You will always get a short circuit rating for the breakers, which will be around 3 seconds. Now, this is just a graph in terms of the percentage DC component in the fault current. Normally, all our breakers are being tested with an X by R ratio of 14. So that comes with a tau value of somewhere around 45 millisecond. Now, this 45 millisecond comprises of somewhere around 35 or 40 millisecond as a. Along with that, when we are reaching to a 45 millisecond tau value, the further critical parameters in terms of reaching to this particular graphical value also plays on what is a breaker opening time, what is your response time. So the opening time of the circuit breaker is a pole opening time plus 10 millisecond of the relay sensing. So that is something described in the next figure. So as what we can see here is that in order to what is required, short circuit breaking capacity of the circuit breaker with a pole opening time of 45 milliseconds. This is just a rough example for a symmetrical short circuit of 21K at a point of installation. So breakers are normally being checked twice. If suppose your percentage DC component while breaking is higher, normally as per the practice, it will be somewhere varying between 36 to 49% for the primary switch gears, and sometimes 36% DC component is being left on the circuit, but that has been as per the type tested reports for the secondary gears. But if suppose you are saying that the percentage DC offset is quite higher, so that's where again factories used to check with their R&D team and then confirm that whether breaker is actually suitable for that sort of application or not. So we can also back calculate the value of an asymmetric based of an IDC, that is a DC fault current, as well as our symmetrical short circuit current, and that's also the value which we need to check while checking the suitability of the breaker. Coming to the next point, these are just this is another variant which we normally offer in the medium voltage switch gear. This is a medium voltage contactor. Now contactors are being predominantly used in a DOL type of starters and for the motor application. So the design of this sort of withdrawable style of contactors as well as fixed. If it is a fixed style contactor, the fuses will be on external, connected from the top copper jumpers. But if it's a withdrawable type of contactor, there is a design that fuses are part of the contactor assembly. So that's an inherent design how vacuum contactors are being designed, are being developed. Medium voltage contactors are suitable for high switching frequency. As we all know that in some of the industries, you require a frequent start-stop activity, so number of switchings will be quite higher. And the area where limitation of applying the breakers in this sort of region is because of its endurance class, as well as the number of switching circuits or switching number of switching permissible number which breaker is allowed, that is somewhere around tested for 10,000 operations. So whenever you are exceeding or you require frequent start-stop activities along the motor circuit, so that's where the contactors are being used in the application. Again, this is just a constructional point in terms of medium voltage contactor. It's developed with the flame retardant plastic to house a vacuum interrupter, metallic chassis, bus parts of the main power connections, magnetic and mechanical linkages. Now there are also different type of designs with different type of vendors. From my experience, this is just shown with an AV, but with wherever we are using a fixed type of contactor application or the other vendor, you might have heard about Eaton or any other vendor. They are developing, or they do have a type tested design where they are using a fixed type contactor along with the 3-position switch from the bus bar, and then having a external fuse connected between bus and the contactor. So it depends upon the design to design, as well as how exactly vendor has developed the product, but that are all accepted products across the market. Also, there is plenty of mechanical interlocks going on in this sort of panels as well. You cannot turn a contactor as well as 3-position disconnector is somewhat mechanically interlocked with each other. So that is also one of the interlock which is being normally seen in the market. Again, this is just a demonstration in terms of disconnector, switch disconnector, earthing switches, and the gas insulated earth disconnector fixed or the rotary. So in terms of this earth switch is normally tested to carry continuous load current with a short time boosted fault current. So earthing switch also has to be tested according to standards. Normally earthing switch it will be switched only when you will be completely isolating your breaker, and there is complete isolation from the bus bar. So that's how the mechanical interlock in an air insulated switchgear with an integral earth switch has been developed. So talking some bit of more in terms of mechanical interlocks of that earthing switch in an AI switchgear. So if suppose we want to have perform any of the earthing operation towards cable, so the first condition is that you need to rack out a breaker, bring out to the test, and then access the shutter for an earthing switch, and then perform the earthing operation. So that's how the earthing operation for the AI switchgear is being done. Now coming to a gas insulated switchgear, it's been normally done by the 3-position disconnector switch, and again in that 3-position disconnector switch, which is connected with a breaker inside a gas tank. So how exactly how it works is that you open a breaker, it's all steady and static breakers. You don't have any withdrawable parts or any sort of mechanism as what we are seeing in an insulated. You need to open a breaker, switch it off, and then turn the 3-position disconnector from connected position to an off, and then from off to an earth. Now this arrangement also changes from secondary GIS switchgear to primary GIS switchgear. Now fundamental difference between secondary and primary from vendor to vendor design can be seen that on the secondary GIS switchgears, your 3-position disconnector switch will be towards the cable and your breaker will be towards connected to the bus bar. But arrangement is slightly reversed. Again, this is vendor specific in terms of primary GIS switchgear, and for that the earthing operation is being done through breaker. So in a normal practice, if suppose we are seeing a secondary switchgear, it will be a bus bar and then line and then a breaker, and then a 3-position disconnector switch which will be connected towards the cable. But this arrangement of bus bar and the 3-position switch is reversed in a gas insulated switchgear. And the earthing operations are being performed by the breaker. In that case, you need to first of all keep the 3-position disconnector switch to earth, and then you need to switch it off to switch on the CB to earth your cable. But that is practice in a primary switch. Again, this is just an application in terms of withdrawable circuit breaker, withdrawable contactors. Withdrawable circuit breaker provides load switching, short circuit protection, circuit isolation when open and drought in the drought position. Cable siders, which is interlocked with the breaker, as I said earlier, and can be closed when the breaker is in drought position. So that's relevant to the earthing switch operation. The protection devices like relays are required to provide on overload as well as short circuit protection. Withdrawable contactor with an integrated fuses, as I discussed earlier, provides the load switching as well as circuit isolation when open and in drought position. Again, as we know that fuses will be coming into picture only during the short circuit cases, and normally motor protection relays MPRs are being used to cater for a motor thermal overload, negative sequence, and all bunch of protections associated with the motor. So that is something separate which motor protection relay will be taking care. Also, carefully coordination in terms of drawing the thermal capacity or configuring the thermal protection of the motor is something needs to be designed carefully so that we do not allow the motor to exploit its thermal capacity. The last one is gas insulated rotary disconnector. Again, a rotary disconnector has a 3 physical operating position. As I said, that it has on, off, and earth position. And these are some of the endurance classes, as electrical as well as mechanical endurance classes for which our breakers are being tested. E0 is normally the standard endurance classes with no fault making capacity. Defines the fault capacity when earthing devices. E1 is an extended electrical endurance capable of 2 fault making operations without damage. Again, E2 is slightly higher with the 5 fault making operations without damage. And mechanical endurance classes are M0, M1, and M2. That's what M2 is something which you will see normally in all of the medium voltage primary switch gears. There are secondary switch gears and its limitation where they have tested the breakers with a lesser operating cycles, and that is M1. So we will see this sort of M1 as a mechanical endurance class only. From what I remember from top of my head will be on a secondary switch gears, but not on the primary. These are just some of the conventional practices what vendor uses in the switchgear in terms of type of CTs. Again, there are different type of CT arrangements and the design in which switchgears are being developed. Normally, wherever you are using ring type CTs, these are all low voltage type of CTs connected and mounted on insulated bushings, which are connected to the lower jaw of the breaker. So ring type of CTs is something also possible to get and install on a medium voltage switchgear, but it comes with a limitation of an insulation, so that's where it is being installed in a insulated bushing. Now, the figure which you are looking on the right hand side is a wound type CT where you have physical bus bars from the cable compartments are connected and passing to the CT, so that's where the short circuit or the KA capacity of the CT also needs to be defined properly, because actually it's been passing, bar is carrying that current through the CT itself. So we need to design a CT keeping its short circuit level also into consideration. Again, this is just a overall view in terms of metering as well as protection class CT. General metering class we would normally use from class 0.5 to 1, but the revenue metering class will be slightly with a higher accuracy of class 0.2 to 0.5. So there is a practice to use 0.2s or 0.5s type of CTs in industries, where your accuracy remains linear right from 20% to 100% of the loading, irrespective of what CT is being carrying in terms of their current. So if suppose my CT is partly loaded or 75% loaded, my accuracy still remains the same, but that's not something which we'll normally achieve with the regular CTs. So it comes into picture wherever there is a criticality or there is an importance to measure the accurate data from the CT. Now again, the protection class CT, we all know that it will be somewhere defined as 5P10, 5P15, and 5P20. This is something just like an accuracy limit factors and how much CT can transform without getting saturated. So, protection class CT provides linear transformation of the primary to secondary current at a higher overall overload levels. The characteristics makes them used for an overcurrent protection. Normally, the relay trip settings have been set for the 10% or 10 to 15 times the maximum load current. This level should fall near to the linear part of the secondary current. So the most common practice is to use 5px, where, as I said, that x is the number of accuracy limit factor. Again, this accuracy limit factor is being derived further into calculation based on the burden rating of the CTs as well. So we need to check that whether my overall short circuit rating, my CT won't be getting saturated under normal condition of the system short circuit, and it's sufficient to perform the protection operation without getting saturation or falling into saturation zone. Now, this is just a quick overview in terms of, I won't touch more on the protection functions, but it's just a quick overview in terms of over protection devices. There are various protections which are being used in our power system, right, say from an overcurrent to an earth fault, line differential to busbar differential, motor protection, ZSIL, ZSIB. These are the concepts, these are the features or the protection parameter features which they are normally using on an IEEE side. So it's just like a reverse blocking, where you see the downstream fault and then send a blocking signal to all of the upstream incomer breakers, so that for a time when it's been blocking all its operation for a overcurrent. And if suppose downstream relay is unable to clear the fault in time, your block will get open in that case, and then allow the relay which is sitting upstream to trip and then isolate the fault. So that's how the ZSI scheme or the reverse blocking schemes are normally being configured in an industry. So again, this is just a quick overview in terms of time over current protection and instantaneous overcurrent protection. Time over current protection provides a load overload protection similar to bimetallic thermal load, except thermal modeling adjusts to strict curves, heating and cooling conditions. Instantaneous provides medium to high level short circuit protection. It does not wait for anything, it will straight away act in that case. This is a graph for overcurrent protection. First one is showing a time overcurrent, where you are coordinating your relay to operate at a specific time and after a specific period of time. And point number 2, in a graph, you can see that it's not waiting. There will be only a marginal gap, marginal fraction of time, and your protection relay will straight away initiate an action for tripping the break and isolate the fault as early as possible. So normally, time over current relay applies to an electrical machine, such as transformer or motor. But again, the differential protections of the transformers are meant to act as fast as possible. Wherever instant overcurrent protections can be directional, which is used sometimes in more advanced selective isolation. So there are systems where you need to apply a directional overcurrent as well whenever you are running a system in a nested parallel let's say you are having an incomer and then also connected with the generator, and then chances of seeing the fault in the reverse direction or the on the forward on it's on the towards the other end as well. So that's why the directional feature also plays an important role in the power system. This is just a basic arrangement in terms of TP connections. I won't deep dive into this one. These are just a quick explanation in terms of differential transformer and the generator application in the bus zone faults. Now in the bus zone faults, the protection is used for on the bus distribution system. The three-phase line currents are measured on the all feeders. So normally it's something we define as a KCL type of rule, right? So whenever there is a bus fault, if we are applying a ZSIB fault, if suppose any of the incomer relay sees the fault and any of the outgoing relay does not see any of the blocking and does not see any of the fault, so it is being sensed that fault will be towards the bus bar and all the feeders on that connected board will be straight away tripped and it will be locked out there unless and until it's been properly addressed. So that's what the concept of bus zone or bus bar differential is. Again, these are some of the gas insulated switch gears. A DGH type of secondary gears and NX plus C, which you are seeing on the right side. NX plus C falls into advanced primary switch gear category, while ADGH is predominantly used on the secondary market. Also, it has a block type configuration, which we normally call as a ring main unit. It has a single tank configuration and it can be straight away deployed anywhere outside. So that's why I have attached catalog and I can share this one at the end of the presentation meeting as well. These are the compartments. I have just shown a top line overview that what exactly the medium voltage circuit breaker in terms of compartmentalize or what are the compartments. A comes with a circuit breaker compartment, B comes with the bus bar, low voltage compartment, gas duct compartment. Now gas duct compartment also plays an important role whenever you are installing the switch gears in any of the substation or any e-houses or a complex substation. So you need to design a e-house or the substations where all these gas ducts are connected together across the switchboard and then it's been vented outside the substation or an e-house. So operator can access in case of any fault seen in any of the panel due to an internal arc. All these panels are normally tested for an internal arc classification, and that is somewhere around, if suppose, let's say my STC value of the breaker is 25K or 31.5K, breakers are normally tested for an internal arc of 31.5 or 25K for 1 second. And that ensures a bit of an operator safety because for 1 second, any of the insertion of an arc inside a switchgear, at least deformations won't be or as per the IEC acceptable limits. So that ensures the protection of a operator standing in front of the switchgear. As we know that the protections will be triggering quite faster than 1 second. So that's the purpose of testing an IEC internal arc test for 1 second in a switch gears. Now, these are just some bits of partitions as well as shutter. So whenever we are racking out any circuit breaker out of the compartment, there are shutters which slides above and below and closes the live contacts. In that case, also there are the padlock provisions which are being provided in the switchgear so that any of the operator or a technician doing any maintenance activity, specifically in this bus bar compartment, after withdrawing the circuit breaker, does not accidentally touches any of the live connection joints there, which are the against which our breaker jaw contacts will be sliding and making the circuit. So it will be having a complete metallic partition, and there will be a sliders, and that sliders also can be padlocked So that ensures the technician as well as operator safety in this case. This is just a type of classification or the categories in which our switch gears have been defined. Normally, medium voltage switch gears will be falling under LSC2V functional category, where all your cable compartment connection, cable compartment to be precise, uh, circuit breaker compartment, and the bus bar compartment will be totally isolated from each other. And that ensures that any of the activity can be done, providing that bus bar is live, and that ensures a bit of technician safety. As we can see, LSC2 category functional unit, it's only a breaker compartment and a cable compartment in a one section, and then switch disconnector in one. So in a LSC2A, you are seeing that circuit breaker compartment, circuit disconnector compartment is something slightly reversed in that case. So coming to an internal arc classification. Now, all our medium voltage switchgears are also defined as per the accessibility based as per classification of an IAC, right? So type A, B, and C are an accessibility levels, which we normally define. Type A is something restricted to authorized personnel only. Type B is normal practices to unrestricted accessibility, include that to the public. And type C is accessibility restricted by installation. So normally, MB switchgears will be falling under accessibility type A, and then how you are accessing an enclosure of a switchgear, either it's from the front side, lateral side, or the rear side, that's defined an AFLR type of classification as a classification there. On the right hand side, there are some of the criteria, past test criteria defined to achieve or to pass through an internal classification. Criteria number 1 defines thus that correctly secures door and covers do not open. This is something relevant when we are sending our switch gears for a internal lock type test, and test results are being approved. Suppose all these criteria has been still kept maintained, and there is no major deformations or no major hot gas is being flown out of the switch gear. So that's how these criteria are being described in an IEC standard. Correctly secured doors and door covers do not open. Deformations, part of deformations are accepted, provided that no part comes out as far as possible, because there is a bit of a space gap, which is a position of an indicator. Now, these indicators are also sometimes of a thick cotton clothes, and these are kept at a distance of 100 to 200 millimeter apart from the testing object. So part of deformation is accepted, but provided that there is nothing comes as far as to the position of an indicator or the walls. Now, criteria number 2 is that there is no fragmentation of an enclosure occurs, neither there is any projection of a small fragment or other part of the switch gears. That's what comes into criteria number 2. Criteria number 3 says that arcing does not cause any holes in the classified sides of a height up to 2000 mm. Criteria number 4, indicators do not ignite due to the indicators means the hot thick cotton indicators which are kept slightly away, as I said, from the testing object. They should not ignite due to an effect of hot gases or an incandescent liquids, or the indicators are the piece of black cotton fabric, as I said, placed, and the object of this particular test is that any of the and if suppose after initiating any of the internal arc inside an enclosure, all these test objects should remain in place, and there should be no major deformations. There should be no fire catching event of any of the cotton fabric indicators, and that ensures that switchgear is sufficient to cater for any of the internal arc for at least the time of cycle for which it's been tested. Also, criteria number 5 is that your earthing point should not get disconnected, and earthing still remains in place. So that's how it's been tested. I will share the result at the end of the uh, slide as the end of the meeting as well, so that this is a worthwhile reading technical paper on safety, which is been given by an ABB. Some of the another products which I would like to uh, showcase here is the concept of all these e-houses and outdoor, we can say, outdoor compact substations or outdoor e-houses. So normally this sort of application comes into picture where they don't want to, there is a restrictions of space or limitation of space, and then they don't want to construct or keep the labor off site, and then these are all factory integrated, assembled, complete e-house and enclosure. So all switch gears, associated fire protection, associated DC as well as AC panel, network cabinets, EMS cabinets, and all these things will be completely integrated at a factory end, and it will be shipped to site completely as a part of product which needs to be just assembled and installed. There is no integration activity on site, so that keeps the labor off site. And industry is also looking to this sort of product, and these are widely acceptable as well. So I guess that is it from. Is there any specific questions? Is there any specific questions on any point?
Hello, Hiren. At
Yeah.
present, we have just one question from the student side. It's a basic questions. He want to know about the unit protection system. What is the unit protection system, and which type of protections will they cover for the unit type of protection?
Yeah, means for normal unit type of protections, we normally use for a unit which is a critical for the system, right? So the transformer differential protection or the generator differential protections, these are all critical protections which is critical to the system. So let's say for the talking from the protection relay perspective, there are plenty of protection devices, RET615, 7UT. These are all devices which are meant for protecting your unit, and that applicable for the transformer differential protection. REF615G, these are also the generator differential protections, also P643, 642. These are all on a couple of other models from the Snyder family as well, and these are specifically used for the gen differential or protection of the gen. So yeah, that is something uh, important to protect, because that's a expensive component. When you look from a power architecture perspective, transformer will be for sure having a cost which will be on higher side compared to all of the other equipment, right from cabling as well as switchgear and all of the other accessories. So practice is to give a more importance on this sort of unit protections.
Thank you, Virat. There are some technical questions, but I would like to ask the questions, not the questions, but I like to ask to share your journey from diploma to your present status. So this will definitely helpful and motivate our diploma and degree students for their study as well as their career. So please share your experience journey from your diploma to present.
Yeah, means I passed out my diploma in 2007, 2006, roughly, and then I was fortunate enough to go for a degree, that too in BVM Engineering College. So I graduated from BVM Engineering College in 2010, but my journey starts from there. That it was not straight away to the level where I am right now. So I started right from very fundamental level. Started to work for Jyoti, and then got an opportunity to work for a Toshiba, then got an opportunity to work for an ABB, and then Wood, and then ultimately I'm working right now in global infrastructure Google. So I would say that it's always better to look to the or try to fetch knowledge right from basics, and irrespective of what you are getting on hand or what you are being offered. But I will say that knowledge should be given utmost priority in first at least 2 to 3 years. Try to grab as much as knowledge, practical hands-on knowledge from the field experts, or maybe from the companies where they are deploying you in the market or on sites. We will all feel that this is not working, this is something not for me. But trust me that that will something will be the best thing ever you will achieve in your life once you go further in your career, because your basics which will be much more clearer from from the from the ground level, and you will be also more confident in terms of facing the challenges of the industry. So I feel that it's always better to start a career. Of course, if suppose you are getting an opportunity in any of the MNCs, no denial on that, and try to gain an opportunity as well. But if suppose we are not not falling into that basket, I will prefer to gain a much more closer experience, on-site commissioning experience. Maybe if suppose you are getting an opportunity design in uh, into design field, or let's say on a consultancy field, that are also the areas which will be much more helpful in future.
Thank you, Viren. So now we have no any questions. So if you have end your talk, then we will end our webinar here. Is there any topic to cover from your side?
Uh, I guess that's it. That is it. Means if suppose any questions or any information from my side, I'll be happy to share. That I'm always available on my LinkedIn profile, so feel free to reach and ask any questions. I'll be happy to uh, give any of the advices, or maybe direct to the correct direction as per my knowledge till date. So I'll just say that best of luck, and I wish you all the best for your future career, as well as and may God bless all of us, all of you.
Thank you, Viren. I would like to also thanks to you. You have
Yeah,
accepted our invitations and given 1 hour. As our timing is different, you have given time according to us. So I'm
yeah.
thanks to from bottom of my heart, and I'm
No, no
also
problem.
expecting your present your association with our university in future also.
Sure. Means as I said that my first one was right from Parallel University, right? So I was quite fortunate enough, and my struggle was slightly different during that phase, and I was also working while learning. So that's how I was looking to my family in that particular phase. So I totally appreciate the support of all our faculty members as well as madam during that difficult phase where I was being landed when I was in during diploma time. So uh, I'm always happy to share any of the ideas, exchanges, or any of my knowledge if suppose it helps to our students, and happy to happy to reach out to you in future as well.
Thank you, Viren. So we'll end our session here, end our webinar. Thank you.
Thank
This is a please end our session. Bridges, sir, our webinar is end. Please end the session.